So in this tutorial, I'm going to be talking about limiting and excess reactants. You are probably wondering, what is so important about limiting reactants and excess reactants? Well, the key point is if you start with, let's say, 35 grams of both your reactants, it doesn't necessarily mean that you're going to end up with 35 grams of your product. It all depends on the molar ratio, not the mass ratio. So the limiting reactant is the compound that limits the amount of product that is formed. And the excess reactant is basically whatever is left over from the reaction you're going to still have in your container. And it's still going to be present. So before I give you an example dealing with chemical equations and how to determine limiting and excess reactants, let's go ahead and start off with an analogy. What if you wanted to make a really good sandwich? And in that one good sandwich, you're going to combine 2 slices of bread with 1 slice of cheese and 3 slices of deli meat. Okay, and I've just written that recipe as if you were to write it in a chemical equation. For every 2 slices of bread, I make 1 sandwich. For every 1 slice of cheese, I make 1 sandwich. And for every 3 slices of cheese, I make 1 sandwich. If you notice, I'm doing like a multiple ratio, just like when we're doing the stoichiometric problems. This is very similar. So let's go ahead and continue talking. What if you go to the grocery store and you end up purchasing a package of bread that has 20 slices of bread and a package of cheese that has 15 slices of cheese. Ooh, let me just go ahead and put cheese on there. 15 slices of cheese. And finally, you bought a package of deli meat that had 30 slices of meat. How much or how many sandwiches can you make using the ingredients that you have? In order to do that, we're going to have to calculate for each ingredient. So let's take the bread first, and let's find out how many sandwiches can we make just from the bread alone. So if we start off with 20 bread, I already gave you the equivalent statement. For every Sammy, I use 2 slices of bread. So I'm going to put 2 bread on the bottom and 1 Sammy on the top, or sandwich. And I end up with 10 sandwiches. Okay, let's go ahead and look at the cheese. For every so we start off with 15 slices of cheese. And for every sandwich, I use 1 slice of cheese. So I can make 15 sandwiches with the amount of cheese that I have. And finally, let's go ahead and look at our deli meat. Our deli meat, we start off with 30 slices of deli meat. And in our recipe, it takes 3 deli meats in order to make 1 sandwich. If I put this into my calculator, I calculate that I can only make 10 sandwiches. Okay, let's look at this. Which of these makes the least number of sandwiches? There are actually 2 of the same ones. So here are the 2 that that limit the amount of sandwiches we can make. We can only make 10 sandwiches with the ingredients that we have. So now we know that we have 10 sandwiches. I can tell you right now, we use up all the bread and we use up all the deli meat. These are what we know as our limiting reactants or limiting ingredients because we use them all up in in making the sandwich. So what we need to find is how much cheese is left over based on the number of sandwiches we've made. So in order to figure that out, we start off with making 15 sandwiches. We could make 15 sandwiches, but we actually only make 10. So we should have ingredients left over for 5 sandwiches. And since we have enough ingredients for 5 sandwiches, let's go ahead and figure out how many slices of cheese are left. And remember, this time we have to go backwards. For every slice of cheese, 1 cheese, I can make a sandwich. So I should have in the very end 5 slices of cheese left over. This is our excess ingredient. Okay, this is the same thing we'll be doing with chemical reactions. We'll start off with certain amounts or certain mass of our reactants, and we need to figure out how much we're going to make of the product, and are there going to be any leftover reactants. That's what we're talking about, limiting and excess reactants. So we're going to go ahead and do one example. The steps we need to consider when we're determining the limiting reactant is that you need to take one reactant and determine the mass of the product one at a time. We have to do this for every reactant that's given the mass until we find the limiting reactant, the one that can make the least amount of the product. So if we look at this, we still, let's go ahead and take this first example. It says here we have iron and steam react to produce ferric oxide or black oxide, and also hydrogen. If we start off with 36 grams of water and it's mixed with 167 grams of iron, we need to figure out how much of the black oxide that's produced. In order to do that, we need to calculate the mass for each. And so, do you remember, if we're going to do a gram-to-gram stoichiometric problem, we need to go ahead and take the balanced reaction and do the mole-to-mole ratio. Since this is already a balanced problem, we're just going to go ahead and do our calculations. So for every 3 moles of iron, I produce 1 mole of black oxide, and for every 4 moles of iron, I produce 1 mole of iron oxide. So let's start with iron. Let's calculate the mass of iron 4 oxide, I guess that's what it's called, black oxide. So if we start off with 167 grams of iron, we need to go ahead and multiply iron by its, divide it by its molar mass, and that would be, the atomic mass for iron is 55.85 grams per mole of iron. And if we take the mole-to-mole ratio in order to find out how many moles of black oxide is produced, you know that 3 moles of iron produces 1 mole of black oxide. And here is where we need to multiply this by the molar mass of iron oxide. So for every 1 mole of iron or black oxide, you end up with 231.55 grams. And if we put this into the calculator, you should end up with 231 grams of black oxide. Okay. Now let's go ahead and find out how much would be made if we used the mass for water. So here's water. Oh, let's go use different pen color. is for water. So we start off with 36.0 grams of water, and we have to multiply that by, or divide that by the molar mass of water. And the molar mass of water is 18.02 grams. Let's go ahead and multiply that by the mole-to-mole ratio of water. So for every 4 moles of water, I produce 1 mole of black oxide. And then again, I have to multiply this by the molar mass of black oxide. So 231.55 grams of iron oxide for 1 mole of black oxide. You end up with 115.6 grams, but correct sig figs, 116 grams of black oxide. Now let's go ahead and look which one has the least amount that is produced, and the least amount produced is 116 grams. So that means that the amount of water that was used in the reaction is our limiting reactant, because this is the one that actually determines how much we make. And we made 100, or we should make 116 grams, not 231. Now, with the next example, you may go ahead and try this for yourself, but make sure you pause, and then I will go step by step to give you the answer, so you can go ahead and check your answers afterwards. So here is our last example, and it says there, what is a limiting reactant when 9 grams of aluminum reacts with 8 grams of sulfur? Now, the first thing we need to really do before we do any stoichiometric problem is make sure that we have a balanced equation. In the last example, I gave you a balanced equation, but in this example, we have to balance it out. So in order for us to have a balanced equation, you have to count the number of atoms or elements on both the reactant and the product side. Our final balanced reaction should be 2 aluminums react with 3 moles of sulfur to produce 1 mole of aluminum sulfate, aluminum sulfide. So now that we know this, we can go ahead and figure out how much of the product we're going to produce. So let's go ahead and look again at the mole-to-mole ratios. So for every 2 moles of aluminum, I produce 1 mole of aluminum sulfide. And for every 3 moles of sulfur, I produce 1 mole of aluminum sulfide. And so let's go ahead and now do the math. Let's figure out which one is our limiting reactant. And let's calculate aluminum first. And if we start with 9.00 grams of aluminum, we need to convert aluminum to moles. So I'll have 1 mole of aluminum on the top. And I have to calculate it, or look up on the periodic table. And the periodic table says the atomic mass is 26.98 grams per mole of aluminum. Now I can go ahead and convert moles of aluminum to moles of aluminum sulfide. So 2 moles of aluminum produces 1 mole of aluminum sulfide. And now I can go ahead and multiply this by the molar mass of aluminum sulfide. So 1 mole of aluminum sulfide is on the bottom. (150.17 grams of aluminum sulfide. And this gives me a product of 25.04 0.005 grams of aluminum sulfide. So now that we have this calculated, we still can't determine which one is our limiting or how much we're going to produce. We need to calculate now for the second reactant, and we start with 8.0 grams of sulfur, and we have to divide that by the molar mass of sulfur, and that is 32.07 grams of sulfur, 1 mole of sulfur on the top, and the mole to mole ratio. So you have, for every 3 moles of sulfur, you produce 1 mole of aluminum sulfide. And I have to multiply it by the molar mass of aluminum sulfide. And then I plug it into the calculator to end up with 12.5 grams of aluminum sulfide. So our smallest number that we would yield would be 12.5 grams. So our limiting reactant is the sulfur because it yields the least amount of the product. I hope this tutorial has helped you understand what the limiting reactant is. The next tutorial should be on how to calculate excess reactants.